when you are active in electronics, there's one issue that is extremely important, and that is the biasing of transistors. There were videos in the past where I call this the working point, setting the working point of a transistor or a field effect transistor. But I think the right word often used is biasing. So that's the reason why I use that word here. And in fact, it's the ultimate success factor when you do experiments, especially with analog circuits, where the proper pure amplification of a sine wave signal is extremely important. But also on switch circuits where a transistor is driven into saturation, etc., etc. Here is the first circuit that I want to show. A classical bipolar transistor, and here we set the biasing, the working point, and in many circuits on the internet, on all kinds of websites, you see here fixed value resistors. And my advice is don't use them, because even slight changes in the setting of the bias of the transistor can give audio distortion or whatever distortion. So this is a classical grounded emitter amplifier. Here we set the amplification, and here the bias, capacitor in and capacitor out, and this capacitor set the frequency band. So on 9 MHz that capacitor is small, and on audio, in the audio band, this capacitor is 10 microfarad. That one is, say, 0.447 microfarad, and here also 0.47 microfarad. Audio between, say, 20 Hertz and 20 kilohertz. So let's see what happens when we change the bias of that transistor. Here is that transistor. This is the potentiometer that sets the bias. 22K or 25K, combined with a series resistor here to prevent the situation that when you turn the wiper to the max, the transistor burns out. So that's a necessary necessary resistor. Let's see what happens. I'm sending in now via the sine wave generator a frequency of 18 kilohertz. This is the waveform at the output of that one transistor amplifier, and I'm now changing here the biasing, and you can immediately see that small changes in that potentiometer value have an extreme effect in terms of audio distortion. So that's the reason why I advise to use a potentiometer in audio circuits. Check the signal with the scope, etc., etc. Or other kinds of generator circuits. Check the signal with the scope. Bias the transistor to its optimum working point. And the circuit works now on 12 volt approximately. And I want to show the effect. When the voltage goes down, and you can see that there is a relation between the pureness of amplification and the supply voltage. It's now 4 volts, but we can bias it, as far as I know, to a proper, more or less proper waveform. Well, that doesn't work anyway. The minimum voltage must be higher, so we go back to 12 volt. Turn the bias potentiometer again. So this is the proper biasing of that one transistor. We now go to the other circuit, and that's the field effect transistor circuit. Here is that field effect transistor. It's a BF245, a N FET, negative FET, and here we have that 4K7 potentiometer. And that potentiometer is decisive for what happens in this field effect transistor circuit. Here are the pin connections. Always use a resistor here of, say, 1 mega ohm up to 4.7 mega ohm. It pulls the gate of the field effect transistor somewhat down to the negative, and the effect is that we don't get all kinds of strange, unexpected effects when the gate is driven by, say, static voltages, hum out of your body, etc., etc. So this is a good resistor to use to make the input of that field effect transistor stable. And here is that circuit again, and let's see what happens when we turn this 4K7 potentiometer. I give the scope somewhat more amplification, and now turn that potentiometer here. Let's see what happens. You can also see here that the different voltages on the drain have a very serious effect on the pureness of the amplification of the sine wave signal. So this is the way to bias a field effect transistor, and then I mean a small signal field effect transistor. And with this circuit that I publish now, there is in fact not so much amplification, but the good thing of it all is that it is an impedance transformer. So here we can connect directly to the gate or via a capacitor of, say, 300 picofarad, a tank circuit, an antenna coil, with a variable capacitor to tune in on radio stations. And then this capacitor must be, say, 300 picofarad, and the output gap here could be between say 1000 picofarad and 10 nanofarad, and after that you can amplify that radio signal extremely with this circuit. So this is the second stage. In that case, this is the high impedance first stage, radio stage, high frequency radio amplifier, and with this transistor it works the BF245. It works up to 15 megahertz. Radio signal in, and here amplify that. Of course, the best thing to do that is to do that with a transistor that has a low noise anyway. So here the really the ultimate success factor when you want to do radio experiments, electronic experiments, want to make a 1 transistor amplifier or a 2 transistor amplifier. Here you see a 3 transistor amplifier. I've only used the first stage, but you can see that here I have 2 potentiometers, in fact 3, and with all these 3 potentiometers you can bias the corresponding transistor. And because of the fact that the first transistor amplifies, the second transistor needs another bias, and the third transistor also needs another bias. And that's a flaw that you often see on the internet, on many electronic websites. The same voltage divider, the same biasing is used for all the 3 stages. But to get it pure, every transistor needs its individual bias. So, pen over somewhat. Field effect transistor, the kind of bias potentiometer, the earth wire is negative, etc. So there's not so much more to tell. And you can use this circuit, for instance, also not only for high frequency circuits, but also for audio filters. Then the audio filters unit is here at the input. Say it's tuned to 2 kHz or 3 kHz, and it doesn't lose its good properties because of the fact that the input impedance here is extremely high. Much more information about that is in my books, and you can find them on the Lulu website. For instance, schematics to audio amplifiers and loudspeaker boxes.